Welcome back for the second part of Lesson 3 on sequences, where we are continuing to look at quadratic nth terms. Before we begin, don't forget that subscribe button though if you're enjoying my lessons or learning from them. So let's jump straight in with this sequence. 4, 10, 18, 28 and 40. Now straight away, if we're asked to work out the nth term of anything, we find the difference. Plus 6, plus 8, plus 10, plus 12. They're all different. So this tells us it's not linear, it's going to be quadratic. So we look at our second line of difference, it's plus 2's. We half that, we times our squared numbers by that to get n squared. This should all be quite familiar to you. This is what we did in the first part of this lesson. If you don't understand what I've just done, please do go back and watch the first part of this lesson, lesson 3a. Now we know there's something to do with squared numbers, so let's write our squared numbers on top. And so far, everything has stayed the same from the last part of the lesson. This is now where it gets a little bit different. What do we need to do to our squared numbers to get to our sequence? We add 3, then we add 6, then we add 9, then we add 12, then we add 15. We're not adding the same things anymore. We are now adding a sequence. So we have a sequence. What do we need to do? Well, we're going to need to find the nth term of the sequence. So if we now write out these numbers that we've added, so add 3, add 6, add 9, if we now write these out as their own sequence, once we've worked out the nth term of those, that's what we add on. So the nth term of this is that there's a difference of 3, so something to do with the 3 times tables. Well, if we write the 3 times table above, we can see it is just the 3 times table, isn't it? So our nth term here is n squared plus 3n. So can you see everything is exactly the same technique until we got to that last bit where they were adding different amounts on. So we just worked out the nth term of that, and that's what we added onto our n squared numbers. Let's look at another one then. 0, 0, 2, 6, 12. We're asked to find the nth term, so the first thing we do is find the difference. How do we go from 0 to 0? We add 0. How do we go from 0 to 2? We add 2. How do we go from 2 to 6? We add 4. How do we go from 6 to 12? We add 6. They're all different, so now we have to look at the second line of difference, which tells us it's something to do with the squared numbers. Add 2, add 2, add 2. Half that, times it by our squared numbers. 1 times n squared is just n squared, isn't it? So once again, we put our squared numbers along the top. What do we have to do to our squared numbers to get to our sequence? We minus 1, then we minus 4, then we minus 7, then we minus 10, and then we minus 13. These are all different, so we don't quite know what we're adding on yet. We have to work out the nth term of the differences. So let's just get rid of everything else and put just our differences there. So we've got minus 1, minus 4, minus 7, minus 10, minus 13. Let's work out the nth term of this. How do we get from minus 1 to minus 4? We minus 3. How do we get from minus 4 to minus 7? We minus 3. Well, actually, we're minusing 3 all the time. So we know it's something to do with the minus 3 times table, which we represent as minus 3n. If you don't know why we represent it as minus 3n, I would suggest going back and looking at lesson 2 of this sequences series, because that's when we look at linear equations writing as an nth term. So we know it's something to do with minus 3n, so I'm going to add minus 3 on there, and I'm going to add my minus 3 times table at the top here. Minus 3, minus 6, minus 9, minus 12, and so on. What do I need to do to my minus 3 times table to get to my current sequence? Well, to get from minus 3 to minus 1, I add 2. To get from minus 6 to minus 4, I add 2. Well, actually, we're adding 2 every time. So we get the answer of n squared minus 3n plus 2. Can you see now? See how much we've taken just our basic knowledge of linear sequences and how we've just built a little bit on there, and now we're finding sequences like this. And the method hasn't changed much. We simply find the difference, find the second line of difference, what n squared numbers are they, write them above, how do we get from our n squared numbers to our sequence. If they're all different, we simply find the sequence of those. Okay? This is a higher topic worth a lot of points in the test, but really We're just using some simple techniques. Let's have a look at one more then. -4, -3, 4, 17, 36. How do we get from -4 to -3? Add 1. How do we get from -3 to 4? We add 7. How do we get from 4 to 17? We add 13. And how do we get from 17 to 36? We add 19. They're all different. So we have to go to our second line of difference. How do we get from 1 to 7? Add 6. How do we get from 7 to 13? Add 6. Second line of difference are all 6's. Half it times our squared numbers by that, we get 3n squared. So we write our squared numbers that have been multiplied by 3 on top. So 1 times 3 is 3, 4 times 3 is 12, 9 times 3 is 27, and so on. So we write our squared numbers out that have been multiplied by 3, because we know it's something to do with the 3n squared numbers. What do we got to do to our 3n squared numbers to get to our sequence? Well, we -7, -15, -23, -31, -39. They're all different, so we know we're going to be adding on another sequence, a linear sequence. So let's work out the nth term to this linear sequence. Get rid of that and bring back all our differences. What's the difference between each of these? We're minus an 8 each time, aren't we? So we represent that as -8n. So I'm going to add on -8n. But it's not exactly the same as the -8 times table, is it? Because if we write the -8 times table here, it's different. Well, by how much? What do we got to do to our -8 times table to get to our sequence? Well, we add 1 each time, don't we? So it's 3n squared -8n plus 1. And that's as hard as it can get, ladies and gents. When you're asked to find an nth term, this is the hardest question you can be asked to do. And can you see? We've not actually had to learn anything new for this second part of the lesson. We simply used how we find basic quadratic sequences. Then when we come across something a little bit different, we used our understanding of finding linear nth terms. And that's all there is to it, ladies and gents. Find the common difference. If we have to, find the second line of difference. That tells us something of the n squared numbers, half it and times it. Then we write those numbers along the top. Then we find the difference. If the difference happens to be different every time, then we simply find the nth term of those differences and add it on. And that's it, ladies and gents. That's the end of lesson 3b. Okay, hopefully you can see why I've used it as a bit of an extension from the last lesson, because they are the same topic. I just think all of this in one would have been a bit too much. But hey, you may have watched these videos next and find it perfectly easy. I've attached a worksheet. Please do go ahead and answer that, and then the answers are also attached as well. I hope you've enjoyed this lesson, or you've at least learned from this lesson. And until the next time where we look at how we use the nth term, stay safe and enjoy.